Hello, and welcome to the AI Research Roundup. I am Alex. Today is May 10th, 2025. We are looking at a fascinating research paper titled Decoding Open-Ended Information-Seeking Goals from Eye Movements in Reading, published just 6 days ago. This paper explores if we can figure out the specific question someone has in mind, simply by watching their eye movements as they read. The researchers used advanced multimodal AI models, which combine text with eye-tracking data, to both classify a reader's goal from options and even try to reconstruct the actual question they were pondering. Alright, so to see how they set up their experiments, Figure 1 gives us a nice example. It shows a paragraph from the One-Stop QA dataset, the collection of reading data they used. Below the paragraph, you see 3 questions. The key concept illustrated is the, quote, critical span, which is the specific paragraph segment essential for answering a question. Notice how 2 questions, Q2 and Q3, share the same critical span, labeled C2 in the figure, making it a tougher challenge for the AI to distinguish the reader's precise goal from their eye movements. Building on that idea of distinguishing between questions, Figure 2 lays out the 2 main types of AI models the researchers used. On the left, we see discriminative models, for example, one called the Hauler Recurrent Neural Network, or Hauler RNN. A recurrent neural network is a type of eye good at processing sequences, like text or eye movements. These discriminative models learn to pick the best option from a set. So they take the paragraph, eye movements, and candidate questions, then score how well each question fits. On the right, we have generative models. These AI systems learn to create new content, attempting to generate the reader's question. Okay, so moving to the results. Table 1 here details the question classification test accuracy. It compares different types of models, including simple baselines, which are like basic comparison points that help us gauge performance, alongside the discriminative and generative models we just talked about. We see accuracies for 3 scenarios: all questions, distinguishing questions with different spans, and the trickier same-span task. The standout is the Robert Eye Fixations model, a discriminative type, hitting 70.9% accuracy for different spans, and, impressively, 57.3% even when critical spans are the same, showing it really can pick up subtle cues. So, while discriminative models are good at picking the right question, Figure 3 here shifts focus to the generative Dalai Lama model, and how well it can actually reconstruct the question a person was thinking. These charts compare its performance using several measures, like BLEU score, which checks how similar the generated question is to the real one, and BERT score, another similarity measure focusing on meaning. We see Dalai Lama, shown by the pink bars, does pretty well, especially when tested on new participants, suggesting it is genuinely learning to form relevant questions from eye-tracking data alone, though it finds new texts a bit harder. Alright, so to see how that very successful Robert Eye Fixations model actually achieves its results, Figure 8 here shows its internal setup. It processes eye movement data through something called an eye projection. Simultaneously, it takes the text from the paragraph and the candidate questions and converts these using word embedding, which is a technique to represent words as numbers for the AI. These 2 distinct types of information are then concatenated, or basically joined together and passed to a language model, an AI specialized in understanding text, and then to a classifier, which makes the final call on which question the reader was likely pondering. Alright, so that was a look at how a discriminative model works. Now, taking a look at another generative approach, Figure 9 shows the Dalai LLAVA model. It has 2 main pathways. One processes textual information, like the paragraph and a prompt. The other handles eye-tracking data, feeding it through a multi-layer perceptron, a kind of layered learning structure. And then 1D convolutions, which are operations adept at finding patterns in sequential data. Both streams are then combined using rotary positional embedding, helping the model understand sequence order, before going into the QN2 large language model to generate the question, with the loss guiding its learning. So to wrap up our look at this fascinating research, it really shows that large language models can effectively decode what a reader is trying to find out, just by looking at their eye movements. A key takeaway is how well discriminative models can classify the reader's question, even distinguishing between questions that rely on the same critical spans, which are those vital pieces of text needed to answer, and generative models show promise in actually reconstructing the question. This all suggests eye movements tell us a lot about a reader's specific goals. That is all for this AI Research Roundup. Thanks for tuning in.